5.2, we'll start off by talking about some vocabulary, just to make sure we're all on the same page. The little 3 up on top here is called an exponent. The 8 is called the base. And when we have a base and an exponent put together, that whole thing is called a power. So today we're going to be dealing with powers and how to simplify them. And I'm going to look at this not from the investigation point of view, but more as just presenting the different properties and some examples of how to use them. The product property says this: when we have two powers multiplied together, same base, we can add the exponents. For instance, x squared times x cubed is equal to x to the 5th. And if you think about that, we have xx times xxx, that's x to the 5th. And we have a similar rule for quotients. So here, like bases, we can subtract the exponents. A couple examples here. X cubed over x squared, 3 minus 2, x to the 1st. Now if we go the other way, x squared over x to the 5th, if we just do straight subtraction, we get x to the negative 3rd. But this third property says that we don't want negative exponents, and we should change it to 1 over the positive exponent. So x to the negative 3rd becomes 1 over x cubed. Personally, I like to look at these types of quotient problems as where are there more x's? In the second case, there are more x's on the bottom. And then I ask, how many more are there down there? There are 3. So I put x cubed down on the bottom. Bottom line with this negative exponent, what you can think of that as is negative exponents move things. If I had 1 over x to the negative 2, that becomes x squared. It's taking the reciprocal of that particular term. And this last property says that anything to the 0 power is equal to 1. 5 more properties. If we have a power raised up to an exponent, we multiply those exponents together. Next property says that if we have two things being multiplied raised to a power, that power applies to both of them. So you have to take a to the x and b to the x. And similarly for a quotient. And this is useful in thinking about fractions, because fractions are quotients of numbers. If I had 2/3 squared, that's actually really easy to do. Seems scary, but all we have to do is square 2 and square the 3. We get 4/9. Last two properties. If a is equal to b, then a to the x has to be equal to b to the x. In other words, if we raise both sides of an equation to some exponent, the equation stays equal because we did it to both sides. And the final property says that if we have two powers equal to each other that have the same base, their exponents also have to be equal. And we'll do some examples that illustrate these properties. So here, example A, like bases, we're multiplying, so we add the exponents. This becomes x to the 12th. Part B, we start with the coefficients. Can we reduce 12 thirds? 12 thirds reduces to 4 over 1. And then we look at the variables. We have x's on the top, but no x's on the bottom to combine with. So we have x to the 8th. We have y's on the bottom, but no y's anywhere else to combine with, so it stays y squared. For C, I'm going to start inside of the parentheses and deal with cubing everything last. 2 over 3 does not reduce. And then here we have x's on the top and x's on the bottom, and it might be helpful to remember that x is really x to the first. So my question is, where are there more x's on the top? By how many? By 3. So I'm going to put x cubed up on top. Now I go through and I cube everything in there since it's products and quotients. 2 cubed is 8. X cubed cubed. Exponent to an exponent, we multiply. And then 3 cubed is 27. One of the biggest things that you all have to get used to is separating off exponents and regular numbers. They follow different rules. We're not doing 3 times 3, we're doing 3 to the 3rd power. And you have to be very conscious of that as you work through these problems. Part D, this is all multiplication. So we take the number parts and we multiply them together. We get 3. And then x to the 5th on one term, x to the 4th on the other term, those have the same bases. We can add the exponents. So 3x to the 9th. Part E, I'm going to start out similar to how I did part C. I'm going to start inside the parentheses and reduce if I can. 10 over 2 reduces to 5 over 1. X to the 8th over x to the 1st, where are there more x's on top? By how many? By 7. So this has become 5x to the 7th to the negative 2. The next step is to apply the negative exponent rule. We have to flip this over. One over 5x to the 7th, and then it becomes squared. The negative exponent flips this fraction over. And now 1 squared is 1. 5 squared is 25. X to the 7th squared, exponent to an exponent, we multiply. So we ended up with 1 over 25x to the 14th. In this problem, we're trying to find x. 8 to what power is equal to 4? Now it's tempting to say 1/2 because 8 times 1/2 is 4. But we want to know 8 to what power is 4. And what we're going to do is we're going to rewrite this, hopefully, using the same base. 4 can be written as 2 squared. 8 can be written as 2 cubed. So I have 2 to the 3x equals 2 squared. So I have two powers that are equal. The bases are the same. That means the exponents also have to be the same. If these two things are truly going to be equal, all parts have to be the same. So since they're both base 2, 3x and 2 have to be equal. I can divide by 3 and find that x is equal to 2/3. And you could check this in your calculator by hitting 8 and then the caret, and in parentheses 2 divided by 3. And that should give you 4. Here's the assignment. Have a nice day.